Welcome to this presentation on AI crimes classification. My name is Fadi Sibai. I work at Prince Mohammed bin Fahd University in Saudi Arabia. This is the outline of the talk. We'll start with the introduction. We'll go over some AI crimes, regulations and ethics. I'll give you then examples of AI ethic principles. Then we'll cover laws for AI. Then we'll move on to transparency and explainability of AI systems. Then we'll cover the classification of AI crimes and the classification tree. Then we'll conclude the presentation. Start with AI is becoming ubiquitous. It's used in identifying lesions in MRIs, in face recognition and biometrics. It's used in self-driving cars, natural language processing in robots and smart cities. AI systems are characterized by three components. They have sensors and perception, for instance, involving vision and recognition. The second component is reasoning and decision-making. That could be done via if-then rules, via deep learning, planning tasks, searching and optimizing solution spaces. And then there's the actuation part, which does an action based on the decision taken. Now, AI systems have risks. For instance, they introduce bias in training. They may lack transparency in decision making. They look like a black box. They can be also used to commit crimes. For instance, we have seen crimes involving invading and exposing privacy, harming reputation, forging personal identity documents, photos, video and audio recordings, and phishing. Phishing could be done, for instance, by forging somebody's voice, making him look like some other person, and to entice the person to release some information, confidential information. And there are AI, crime predicting AI could misclassify individual as a criminal or a terrorist. AI could be involved in giving false recommendations for false stock purchases. And this could be done by manipulating the news of the stock company to make the stock price go up or down. And AI has been used also in personalized political ad hacking and election fraud. So in this paper, we review prior work in AI ethics, and we present a classification tree for AI crimes to support AI crime investigations and regulations. AI crimes in 2009, at the École Polytechnique Fédérale of Lausanne in Switzerland, robots were programmed to work together, and they end up learning how to lie to each other. And the researchers root caused and found out that that was because the robot used fixed goals, whereas humans doing the same task were able to change their goals when they found that the original goals conflicted with common ethics. In 2019, Amazon admitted employees listened to customer voice recordings on Echo and Alexa enabled smart speakers. Also, Apple admitted that Siri saved customer audio to enhance its AI. So there's an invasion of privacy here. In 2019, a Uber robocar in Arizona hit and killed a pedestrian. And we have cases from the law offices of Mr. Akrizadeh, Cruz versus Talmadge, where we have a claimant being injured when his bus got hit, where the bus hit the bridge, and claimed that the bus driver used a failed GPS and sued the bus maker and bus company. In Nelson versus General Motors, the claimant sued General Motors for a self-driving vehicle entering his property and injuring him. And Holbrook versus Prodomax Automation, a worker was killed by a robot. The claimant asserted that the robot should not have come into the victim's work area and sued the robot maker. So according to Teaking and all, AI crimes can be characterized by 1, the likelihood, plausibility, uniqueness, and criminalized in domestic law. Likelihood means that the crime occurred or is likely to occur. Plausibility means that the AI technology can technically lead to such outcome. Uniqueness means that the crime requires AI as an essential factor or ingredient, and criminalized in domestic law, meaning that there is a domestic law categorizing the act as a crime, and that excludes international and war crimes. Regulations and ethics. There are a few regulations and ethics related to AI, but here are a few. In the US, there's the AV START Act. That's a US Congress bill for driverless vehicles, establishing a federal framework for ensuring the safety of highly automated vehicles. There's also the Future of AI Act, that's another Senate bill for establishing an advisory committee on the development and implementation of AI. In the absence of AI-related laws, car companies such as Volvo and Daimler Mercedes-Benz publicly accepted responsibility and full liability when their AI-augmented cars are operated in automated or autonomous mode, which means they're self-driving, not requiring a human driver to take control of the car, and get involved in a car accident. So that's a big responsibility anytime a Volvo or Mercedes-Benz car is involved in an accident and it's operated in autonomous mode, then Volvo and Mercedes-Benz take full responsibility and full liability of the accident. Using AI and non-customized conventional software, the US courts and the Uniform Commercial Code have treated this software as a product subject to strict liability. So the stakes on AI developers and testers to produce robust, safe, secure, and therefore trustworthy products is great. The independent high-level expert group on AI in Europe has developed requirements for trustworthy AI. And this is to gain the trust of the user. The AI system should meet 3 requirements through the system's full life cycle. The first requirement should be lawful. It means it should comply with all relevant laws and regulation. And then the trustworthy AI system should be ethical by being loyal to ethical values. And then the AI system should be robust, i.e. predictable to stakeholders and robust against manipulation, tampering, and malicious use. Now, a lot of discussion on ethical values for AI, and they span a very wide range. They go from respect for human freedom, fairness, transparency, explainability, auditability, and accountability, to prevention of physical, emotional, financial harm, and communicating AI systems capabilities and limitation risks to consumers. Examples of AI ethics principles. There's the European Group on Ethics in Science and New Technologies, Statement of Artificial Intelligence, Robotics, and Autonomous System, proposed a set of 9 basic principles. 4 of these 9 principles must be followed in order to ensure that AI systems are developed and used in a trustworthy manner. IEEE has the IEEE Global Initiative on Ethics in Autonomous and Intelligent System. It has 12 general principles. 8 of these principles are related to AI and ethics. There's something related to human rights, well-being, data agency, effectiveness, transparency, accountability, awareness of misuse, and competence. Then we have the major technology companies such as Microsoft. The Microsoft AI principles. Designing AI to be trustworthy requires solutions that reflect the ethical principles of 1, fairness, 2, inclusiveness, 3, reliability and safety, 4, transparency and understandable, 5, privacy and security, 6, accountability. Google has these principles. The AI system should have social benefits, avoid unfair bias. 3, be built and tested for safety. Be accountable to people. 5, incorporate design principles. 6, uphold high standards of scientific excellence. 7, be made available for uses that accord with these principles. Then we have Isaac Asimov 3 laws of robotics, and we have the 5 UK principles of robotics. After we study the directions in which these principles take, we come up with the following graph. We find that these principles really target, 5 of these target guard against misuse, including privacy. 4 of them target accountability, 2 target transparency, 2 target fairness, and 2 target well-being and society benefits. So the majority of the areas targeted are by these principles are guard against misuse, including privacy and accountability. As far as laws for AI, they're really lacking, but there are 2 cases. There are hard laws and soft laws. They differ in how precise the rules are, how much legal obligation these rules set forth, and whether the rules authorize a third-party decision maker for law interpretation and implementation. In general, hard laws refer to law-binding obligations that are precise or became precise with later regulation. Well, they can be enforced in a court of law. They authorize a third party to look over their interpretation and enforcement, and they're characterized by a coherent and formalized framework to ensure smooth implementation and enforcement of commitments. On the other hand, soft laws exhibit softness and flexibility. They're less formal along precision, obligation, and delegation of authority dimensions, and they're found in international environments such as international law and United Nations resolutions, and they minimize initial contracting costs and facilitate speedy conclusion of agreements, thus aiding bargaining and negotiation and eliminating the need for challenging approvals. So in AI, what should we do? In general, when we have the crime is very clear, hard laws should deal with that. And for crimes that are not very clear, for instance, we don't know how much involvement, human involvement is, and how much is because of training and machine acquiring experience from another machine. So soft laws can deal with these cases better. In any case, to gain the trust of the users and deter crimes, we need more regulations to regulate and control AI system crimes. Now we move on to transparency and explainability of AI systems. They correlate very well with user trust and confidence. AI systems differ in the degree of transparency and explainability depending on the technique used. So for instance, we can have AI systems using deep neural networks, or they can use decision trees in the middle, or they can use Bayesian networks. There are other techniques. But the deep neural network here, we have different layers of neurons. The neurons are in blue here. And we could end up with tens of these layers, and we have the input layer here and the output layer here. And neurons in one layer connect to neurons in the next layer via connections or links, which have weights which are updated in every training cycle. Now, when the neural network makes a decision, it's very hard to trace and find out which neurons and which weights, connection weights, really impacted the decision. So this is an example of a less transparent technique. Opposed to that is a decision tree. For instance, here we have a decision tree where we decide whether we should admit a student from high school into college or university. And in this decision tree, we ask, is the student, has the student passed the high school? Did he complete the schoolwork? And does he have a certificate from the high school? If yes, then we ask, did the student score on the university admission exam, is it higher than 1200? If so, then the student is admitted. If it's less than 1200, he requires or she requires a preparatory year to remediate the weakness that he or she has. And if the student didn't complete the schoolwork, he cannot be admitted into college and university, he's rejected. So looking at this decision tree is very simple and straightforward to know how the decision is made by just tracing the different condition path. Similarly, for a Bayesian network, we have an example of a Bayesian network to predict how many coffee drinkers, drink dark coffee or coffee with sugar or coffee with cream. And in this example, we have 60% drinking dark coffee, 40% coffee with cream. Of those who drink dark coffee, 30% drink it with sugar and 80% drinking it with cream. So if you want the system to predict how many persons drink coffee with sugar, we can add the path on the right and the path to the left. On the right, we have 0.4 times 0.8 is 32%. And on the left, we have 0.6 times 0.3 is 18%. 18% plus 32% is 50%. So the system can predict that half of the coffee drinkers drink it with sugar. Again, it's very easy to decide how the system predicted such outcome based on this diagram. So the two examples in the middle and the right are transparent, the one on the left is not. Now, making the source code open source does not make it comprehensible nor transparent, because we can have spaghetti code that is very incomprehensible to the consumers. Transparency has a negative side. It assists in reverse engineering. It could be exploited by hackers to reverse engineer the system and device his attack, but it has two advantages. Transparency assists in uncovering hacker exploits and expose their work. It can also assist in assessing how smart or safe an AI system is. An interesting paper by Gilping et al. In 2019 argues that AI systems should be more than transparent. They should be explainable. That means they should be able to explain their decision making. For instance, prove that the system was not trained with biased data, therefore leading to biased decisions. And explainability is not natural nor intrinsic in the system. It has to be built in and carefully designed. For instance, to make deep neural networks explainable, researchers have proposed three ways. One is to build equivalent simplified models emulating the original model. The simplified model is easier to explain how it arrived to a decision. Two, map neural network layers with connections highlighted according to activity and impact on the decision. So for instance, here we can highlight the connections that made an impact that led to the condition in yellow, and the consumer and user can trace that and know why the system came up with the decision. Or we can embed and build in explanation subsystems for explaining the system's behavior. Now, transparency and explainability are necessary to investigate AI crimes and weighing man versus machine responsibility of these crimes. Now we move on to the classification of AI crimes. Regulation and legislation is required to control the malicious usage of AI systems and penalize AI criminals. We searched the literature. We didn't find many classification of AI crimes. There's the work of King and his team, which classified AI crimes based on different types of AI crimes, such as crimes against the individual, financial crimes, sexual crimes. And with each class of these crimes, King and all associated the number of articles addressing these crimes found in the literature. And we didn't find any classification of AI crimes classifying the crime based on the type of criminal and whether there is intent instead of the type of crime. So the classification tree that we present here helps in crime investigations and regulations, and it's developed from scratch with no links to prior work, and it's based on who the man and or the machine is involved in the crime, whether there's intent, human intent to commit the crime or not. So the AI crime classification tree starts by asking, is a human involved in the crime? If a human is involved, we continue that on the next slide. If a human is not involved, that includes the cases with no apparent human involvement or very hard to sense human involvement, such as machine superintelligence. So although machine superintelligence may be years away from today, it's possible, nevertheless, for humans to design such a machine without knowingly or fully knowingly anticipating the machine's fully risk to commit the crimes. So for instance, the machine might have boosted its intelligence as a result of acquiring multiple and various machine learning experiences or associations. It might have acquired unhealthy thinking, which led to attaining its level of intelligence and its developed tendency towards crime. When such a super intelligent machine has been proven to commit a crime, various laws have to be developed and applied, including downgrading the guilty machine's capability up to terminating it for serious offenses. And there is a debate of should we terminate all machines, similar machines of the same type that acquired similar experiences and therefore might have developed similar tendencies to commit crimes, or should we just penalize the machine that committed the crime? So all of these are debatable and out of the scope for this paper, but it's something to ponder upon. Now, in case the human, actually before we move out of this, the case on the right also involves cases where it's very hard to sense human involvement. So not necessarily it's a super intelligent machine, but also cases where it's very hard to prove that the human really intended to commit the crime. So for instance, you can have a case of a machine committing a crime, but it wasn't clearly provable that the designer and the tester and manufacturer of the machine really had responsibility and therefore liability in the crime being committed. So these also cases fall on the right side. Now, in case a human is involved in the crime, we go to, and here we have cases of if the crime is intentional or not. If a human is intended to commit the crime, the tree diverges to the left side. If a human didn't intend to commit the crime, the tree diverges to the right side. On the left side, we have the case of the human had a goal and intent to commit the crime. So not only he was involved in the crime and intended to commit the crime, but he also had a specific goal. So for instance, knowing exactly what to do can be done by the human or the human group or team tweaking the software and hardware precisely to cause damage and cause the system to commit a crime. Or there could be the cases where the human doesn't affect the algorithms and the software and the hardware, but is involved in the training and interferes with the training and guides the training so that it includes cases that leads the AI system to be trained and make a decision to commit a crime. So when there's goal and intent to commit the crime, we need to distinguish between crimes based on their severity and damage, whether the human intended to kill, intend to hurt only, intend to delay reaction of the system, or intend to reduce the capability of the system. So therefore the law should impose different penalties based on what was intended. Now in case the human or the human team were involved in the crime and they had intent to commit the crime, but they didn't have specific goals. For instance, they could be doing that by reducing the accuracy of the AI system, its predictability, or maybe reducing the number of training iterations so the system is not trained enough to make the right decision and therefore to commit something criminal or damage causing. So that includes training sabotage, which itself includes the cases of instantly, haphazardly, or aimlessly reducing the number of learning iterations or learning rate or other learning parameters, thereby decreasing the system's accuracy or increasing the error or cost function. For instance, you can have the criminal deleting test cases or learn cases similarly reducing the system accuracy. This may happen when the criminal did not have enough time to plan his crime, but seized the opportunities to sabotage the system with available instruments or ways. So there's no time, there is no specific role. The criminal wanted just to cause some damage, but no specific damage in mind. Now, on the other hand, when the crime is not intentional, we have the case of negligence here. And negligence can have three subcases. We have the case on the left. There's no due diligence in design. For instance, the developer or designer of the system, the AI system, did not exercise much diligence in thinking about reliability of the system, its resilience, its robustness, and may not have added spare parts when he could have. And so based on the lack of diligence in the design, the system led to a crime causing action. Or there could be negligence in testing. So there's no due diligence in testing, and that ranges from no testing at all, and that's a severe crime, to insufficient testing conducted to improve but not fully assure system robustness. Or in the case to the right, there is the case of failing to warn the public. So here we have the manufacturer with the designer, developer, and tester knowing fully about the capabilities and limitations of their design systems, but they don't warn the public and the consumers about the risks of the system limitations. And that's also very severe. So the consumer may trust the system in different operational modes, but these systems may carry risks that the consumer may not be willing to take, only if he was or she was warned previously about these risks. So here we have the negligence of the manufacturer to warn public about the limitations and the risks taken by consumers. And on the extreme right, we have the third party, and that covers the cases of the human not being really responsible for the crime. So that could fall, that could have two subclasses, tricked by third party and coincidental. Tricked by third party means that somebody else intended for the crime and planned for the crime and made it look like the accused did it. So for instance, the planner might have wiped out all traces or evidence, resulting in the main suspect being accused. Or we can have the accused being forced involuntarily or unwittingly by a third party to do the wrongful act. For instance, a self-driving car hacked by a third party to crash. So the driver of the car is accused of committing the crime, although he didn't plan or really didn't commit the crime. A third party did that. And then we have the case of coincidental, which is accidental. Here the accused nor any other human intended nor planned to commit the crime, but accidents or circumstantial events led to the system erroneously functioning. In that situation, the third party is really luck or fortune. In conclusion, AI technologies are being spreading in cyber-physical systems and smart cities. AI crimes can have disastrous consequences when used in cyber-physical systems and smart cities. This paper reviewed ethics in AI and presented an AI crime classification tree to assist in crime investigation and regulation development. And based on these AI classes, it is hoped that regulations and legislations will be developed to control AI crimes. So there should be regulations and laws for each of the classes in the classification tree, treating negligence, intent and goal, and also the intent and goal. Is there intent to kill or just to harm or just to hurt, etc. Depending on which of the above classes of crime an AI crime falls in, different laws and regulations should apply, and they should inflict more severe penalties on more serious crimes to prevent future recurrence and deter others from committing these crimes, where seriousness gauges the crime damage, the crime impact, and the crime spread. And intentional crimes should result in harsher penalties than non-intentional ones. Intentional crimes with intent to inflict maximum damage should weigh heavier than those with intent to inflict less damage. Also, AI systems should be designed to be transparent and explainable. This will help the AI system, intelligent system products to gain the trust of the consumer and the user, but they also assist in tracing the hacker exploits and the intent to commit crime. So they help in the crime investigations. And finally, exam-based certification of AI code developers and testers will be required to validate AI systems and to help gain user trust and reduce the number of AI crimes by emphasizing diligence in design and test. So this concludes this presentation. Thank you for attending, and this is time to answer questions.
Okay, thank you, Fad. Due to time, I would stay here discussing about the AI crime along the day, but as we have time, I'll do just one question for you, okay? It's a very interesting question. What do you think? Do you think that the requirement for AI models should be explainable and will take away from the opportunities to building complex models?
Yes, Explainability is very important. Transparency is very important because it allows whoever is doing the forensics and the root causing, investigating the crimes to really trace how the decision making was done. So with a system that is transparent and explainable, it will be straightforward to trace how the system came up with the decision. And based on that, it helps, allocating, responsibilities and liabilities. So it is a very important requirement for AI systems to be transparent and explainable. And I believe this is a new trend in AI system. I believe one of the papers in this actual conference was about explainable AI in health. So this is a growing area, and yes, so definitely this is the case. I agree with that.
Yeah, okay. So I would like to thank you. Unfortunately, we don't have time to do more questions. So I would like to ask who has more questions. You can address to the Fadi Sibai.